All right. So we want to use the Lagrange multipliers to find the maximum and minimum values of the following subject to the constraint. Okay. So let's look at our test points. So we might need way more room. All right, so the test points satisfy and then okay. So what that gives us is okay. All right, so from the first equation, either let's just do it in a different color. Either x equals 0 or that equals 1. If x equals 0, so if we go with x equals 0, then the third equation would give us y equals plus or minus the square root of 3 halves, yielding 2 test points. So that would give us 0 square root of 3 over 2 and 0 negative square root of 3 over 2. All right, so if lambda equals 1, then the second equation implies y equals 0 or y equals 4 square root of 21. So for y equals 0, should come down this way, for the third equation, then you would get x equals plus or minus square root of 3, which will give you 2 more test points. The square root of 3, comma 0 and negative square root of 3, comma 0. All right, for the y equal to 4 over 21, then the third equation would give us x equals plus or minus square root of 1291 over 21, which would give us 1291 over 21, comma 0, nope, 4 over 21, and then negative square root of 1291 over 21, or 4 over 21. Okay. So then, to finish it out, you just have to put them into the function. This function, do it on the page. So the function is f of xy equals x squared plus 7y cubed. So that gives us f of 0, comma, 3 halves equals 21/2. Okay. And you guys can definitely go through verifying. All right, so then what that tells us is the maximum value, and -21/2, 3 halves is the minimum value. All right, so that is the real first question. Oh, yeah, let's. Oops, put it on the wrong page. All right, so this one is a little bit easier in my opinion because we're just going to use the definition of the Jacobian. So I'm going to do -32/7, 1/3 plus 32/7 u/v². So that gives us negative 32. And you guys can work your own problems out if you want. Just if you get stuck, you can always watch the video. Make sure you work through your own. Don't just rework these. If you work through your own, then it will like it'll give you a good feeling for if you're working through everything okay. Come on. Okay, so you guys can see for this one it says consider the vector field f if f x y is equal to negative I plus 2j, which of the following vector fields correctly shows the graph. So you can see they give you 4 options. It says examine the components of the vector field. The negative value of the coefficient of the unit vector I determines the direction of the vectors from the area with greater values to x and the area with smaller values of x. The positive value of the coefficient for the unit j determines the direction of the vectors from the area with smaller values of y to the area with greater values of y. Therefore, the vectors of the vector field are directed along the parallel straight lines with a negative slope. Thus, this graph is correct, which is the first one. Okay. Going to switch back now. Okay. Back into here. All right. Hopefully that one is good for you guys. All right, find the integral along the curve, which is given by x equals 2t, y equals 3t, and then t is between 0 and 1. Uses symbolic notation and fractions where needed. Use the integral along the curve, which is blah. Okay, so we're going to use the value of the line integral theorem. Using value of a line integral. So we're gonna let C be a smooth curve defined by the parametric equations x equals x of t, y equals y of t, and t is between a and b. All right, so we let z equal f of xy be a function that is continuous on some region that contains the curve C, then the line integral of f along C from A to B exists. So then we have Okay, so the derivatives would be, so these derivatives would be dx dt equals 2 and dy dt equals 3. So if you put everything together, probably easier to do it on another page, you would get 5x plus y to the fourth ds is equal to 0 to 1 10t plus 3t to the fourth square root of 2 squared. Oops. Sorry, messing up my signs. Okay, so that's going to give us 25 plus 81 over 5 square root of 13, which is 106 over 5 square root of 13. The threes today. Oh my goodness. You guys saw that. All right, so now it says find the line integral using the value line theorem. So that is the first answer. It looks like they want a second answer. So then what we would do on this part is it. We're looking for the integral c 2x plus 11 y squared ds. So what we know is that if x equals x of t equal to sine 3t and y equals y of t sine 3t, those are the same, just making sure. So what we get from that would be Okay. Sorry for not talking. I'm kind of zoning. If anyone has any questions, you can definitely ask them. I'm just trying to get this down for you guys. So then we end up with 14 over 3 square root of 2. Okay. Right. Um, okay. I think it's this one. Alright, hopefully I didn't skip one. We'll just count at the end to make sure. Alright, so use the vector field and the curve to find the line integral. Right. So along the curve C, obtain that we would have, alright, so along the curve C, obtain that x of t equals 3e of t, y of t, e to the negative t, z of t equals t cubed. It's going to be t from 0 to 2. So that tells us vector f x t y t z t is equal to 5 y t I plus x of t squared j plus x of t times y of t times z of t. Okay. So if you fill all that in, you end up with 5 e to the negative t I plus 9e to the 2t j plus 3t cubed k. All right, so then we have dr equal to 3e to the ti minus e to the negative t j plus 3t squared k dt. So then f dot dr is going to be 15 minus 9e to the t plus 9t to the fifth dt. All right, so then we need to squeeze in as well the integral. So then that's 15t minus 9e to the t plus 3 halves t to the sixth, 0 to 2, so 30 minus 9e squared plus 3 halves times 6, no, 2 to the sixth. So that gives us an answer of 135 minus 9e squared. Okay. Okay. All right. So this one says let the vector field be the following, be a conservative vector field. Find the potential functions for the field. So if we're looking for f of xy is the goal, not doing Christmas. Then we would have delta f equal to f of xy equals ye 7x I plus e to the 7x over 7j. So then we're going to let pxy equal ye to the 7x and qxy all right, so then we have the integral pxy dx equal to okay, so differentiating this expression with respect to y. setting it equal to q of x would give us, I'm just gonna do it in the same spot, equal to qxy, so 80 to the 7x, 7. That would give us h prime of 0, or of y, sorry, equal to 0, so h of y is equal to k. So then we have f of xy equals y over 7 e to the 7x plus k. Do me a favor, as we're doing the next one, if someone can just go and count how many we've done. I may have skipped one. I mean, it's not a big deal. We can go back, but we just have to make sure we cover all 10. All right, so let me get this problem for you. And then I want you to have the plot of the region as well. You will have to do this part on your test alone, but I am giving it to you. Okay, so this says, use Green's theorem to find the area of the region bounded by blank and blank, and make sure that you use how you want to write stuff. So, determine the limits of integration for x. All right, so we treat this as an x simple region. Then the Green's theorem for the area is trying to squeeze this on here for you guys. I think it'll fit. Oops. So that's going to give you 28 square root of 21 as your area. Okay, cool, thanks. Hopefully we have 3 more questions. 8, 9, 10. Hopefully we have 3 more questions. If not, we could be in some trouble. No, not really. Just figure it out. Okay. The next one's significantly long. That's okay. Still have time. Still have plenty of time. All right, and then let me get you what the surface looks like. What I'd really like to do is give you a decent amount of this. Let me see what all is set up. All right, so I'm definitely giving you this. Can I consider the plot? Okay. And then I also want to give we might do the rest of the problem on the next page, on the next slide. Trying to set it up for us. All right. Okay, so this is so we want to find the mass of a fluid with a constant mass density flowing across the parabola in a unit of time in the direction of the outer unit normal if the velocity of the fluid at any point on the paraboloid is the following, express it in blah blah blah. So then you have this setup work. Right, and now we're gonna find the mass. R d theta. All right. Okay. Minus R sine theta j minus R squared k. And then we gotta squeeze in and then it's gonna be negative 2r squared cosine theta I minus 2r sine squared theta j plus rk. All right, nice. I like that I was able to squeeze in there. Right. And these parts cancel. So we just have what's left, 0 to 2 pi, 0 to 9, negative r cosine theta I minus r sine theta j minus r cubed r squared. All right, so then what we have next is 0 to 2 pi, 0 to 9. And it's 2r cubed cosine squared, 2r cubed cosine squared theta plus just happened plus 2r cubed sine squared theta minus r cubed dr d theta 0 to 2 pi 0 to 9 r cubed dr d theta 0 to 2 pi 1/4 r to the 4th 0 to 9 0 to 2 pi 6,561 over 4 d theta is going to be 6,562 over 2 pi. Okay. All right. Next one is not as long. I'm also going to try to stay by the computer for a little bit tonight so I can go ahead and make sure I put this up for you tonight so you have it. All right, so it says find the divergence of f equal to the following express using stuff. So by definition, the divergence of the vector field is div if div 5 x y e to the z I plus 6x squared e to the z j plus 6x to the 5th y e to the z k. Okay. Okay, so that gives us y 5y to the z plus 0 plus 6x to the fifth y to the z. So that means we can just do 5 plus 6x to the fifth y to the z. And that is your answer for that one. All right. All right. So let f of x, y, z be the following. We want to find the curl. So using the symbolic determinant to find the curl of f. So the curl of f, not to be confused with Carl off of The Walking Dead, everybody's least favorite character. Okay, so 6 cosine 2x, 3 sine. That was not what I said. 3 sine y, 6 to the 4x z. And hopefully we'll have enough room. All right, so if you work all of that out, you're going to end up with a negative 24 ze to the 4x z j. But I want to write it nicer. bugging with me. All right, negative 24 E, nope, Z. And then it's 4E, 4X, goodness, Z, J. Okay. All right.